Let's do one last example, but this time let's switch around whether we're talking about Poisson or whether we're talking about exponential. Okay, so here automobiles arrive at a toll booth at a rate of 8 vehicles per minute. Here, because I've got counts per minute or per time, 8 is actually lambda. Okay, anytime I've got counts per time or per area, that is lambda. So here, lambda is 8 cars per minute, okay, between these 2 hours. Assume the number of automobiles arriving at the toll booth in this hour can be modeled with a Poisson. Okay, so here, how do I know it's Poisson? It's talking about the number of cars. When I'm talking about the count of events or successes happening, that is discrete. Okay, so that would be the discrete way of talking about the situation. When you're talking about the number of counts, that must be Poisson. If I'm talking about the amount of time until a car arrives, then instead of Poisson, I'm actually talking about something continuous. I'm talking about time per success. If I was talking about the amount of time that goes by, then this must be exponential. So what is the probability that 6 vehicles, so what is the probability of 6 events happening in any given minute? Okay, so here I'm talking about counts per time. This must be Poisson. I'm talking about discrete things. The amount of vehicles is discrete. It's 1, it's 2, it's 3. It's not 3.7. Okay, you can't have 3.7 vehicles. Okay, so this would be the Poisson way of thinking of this. What is the probability of exactly 6 vehicles in any given minute? Here I have lambda given to me in terms of minutes, so I don't need to do anything special. This is just let y be the number of cars per minute, which is Poisson. So what's the probability of exactly 6? Again, you can use the formula if you want, or you could use Minitab. Okay, probability distributions. This would be Poisson. Where are you, Poisson? Okay, so here I want the exact probability. I'm expecting 8 cars per minute, and I want to know the probability of exactly 6 cars. And you can see then, here's the calculation. It's about 12% chance that I get exactly 6 when I'm expecting 8. Okay, starting at 2 o'clock, what is the probability it will take at most 0 seconds for the first vehicle? Sorry, not 0, that's a 10. At most 10 seconds for the first vehicle to arrive. Now we're talking about time. Okay, so what's the probability that it'll take some amount of time until the first success? Time per success. This time we're talking about exponential. Okay, so here let x be the amount of time in seconds until the next count or the next event. Lambda was 8 cars per minute. Okay, let's change it into terms of seconds. So that would be 8 divided by 60 cars per second. That's lambda. Instead of events per time, let's do time per events. Okay, so then all I need to do is just take the reciprocal of 8 over 60, which would be 60 over 8. That number happens to be 7.5 if you take 60 divided by 8. So it would be 7.5 seconds per car. Okay, so let x be the amount of time in seconds until the next car. X must be exponentially distributed. What's the probability it would take at most, okay, at less than or equal to 10 seconds to see our first car? Okay, again, you can write this by hand or using Minitab. Go to Calc, probability distributions. This is the exponential distribution. Okay, here I said it was, we expect 7.5 seconds to go by for every 1 car. Here, what's the probability then of at least 10 seconds going by before we see our first car? In this case, we have the number of seconds. We want the area, so this would be the cumulative probability, the less than or equal to sign. The probability is somewhere around 74%, as you can see here. If, okay, so anytime you see this if, you know a condition is coming. If an automobile has just arrived, okay, so given something's just happened, what's the probability the next automobile will arrive within 4 seconds of that first one? Okay, well here we don't need to worry about the condition just because exponential has the memoryless property. So instead of doing a conditional statement, which is overcomplicated, we know this is just the probability of starting over. Okay, so just instead of imagining something just happening and then what's the probability that something else happens, because it's exponential, I can just simplify and say, let's just start at 0 time and say what's the probability of a car arriving within 4 seconds. That's what the memoryless property says we can do. So here, what's the probability of a car happening to come in the next 4 seconds? Calc, probability distribution, exponential. Here, same question as B, except for instead of 10 seconds going by to see a car, we want the probability of only 4 seconds going by, at most 4 seconds going by. The probability of that is about 41%.